Okay, so again, Joe Armstrong here. Welcome everyone. This is the second in a series for the Power Systems Virtual User Group webinar. Hope everybody is doing well, and just want to say welcome. Again, we're covering part 2 today of Oracle Best Practices. So last week we covered part 1. The replay, the presentation materials, a link to the replay are all up on the wiki site, so you can go and look at that if you missed it. We did a Q&A from in there, and we have a Q&A document, and I apologize, I haven't quite gotten it up there yet. Ralph sent it to me last week or this week or whenever, but I am getting that up there, and it should be up there probably later today. And then from today's webinar, we'll do the same. We'll collect the Q&A, and Ralph has been really good about answering the questions that we don't get to, and then we'll put that up for today's session. So there's two things in the WebEx, 2 panels that you can get on and do stuff. There's a chat panel and a Q&A panel. I ask you to please put questions in the Q&A panel. That's the one that I'll monitor for questions. The chat, I don't care, put anything you want in there, but for questions, we're going to be monitoring the Q&A panel. So otherwise, the presentation materials for today are up on the wiki. And Ralph has said that he's got so much information. I mean, last week was a lot of information, but he's got so much more information today, and that I/O is very important for, which we're covering today, I/O and miscellaneous. It's very important for Oracle performance. So he's got a lot of information to go through. And rather than spend time introducing Ralph all over again, I'll just say that he is an Oracle performance expert guru, has been working at it for a long time with IBM. And with that, Ralph, I'll just turn it over to you.
Thanks, Joe. Appreciate the introduction. So everybody who is on the call, thank you for taking the time to attend this second part of the education session. Topic, as Joe already mentioned, is really focused on I/O and some miscellaneous topics at the end. The number of, if you carefully monitor or look at the slides, you will see that the page numbers at times jump significantly. We will, after the presentation, make available a full slide set where there is, for some of the technical details and how to, a significant number of additional slides in the full deck you probably want to have a look at as well. My focus is really more about the concepts and how to best utilize. Now I have to find my mouse. So I/O network, and then a little bit about Oracle patches and some miscellaneous. So I/O, key part of an Oracle database, the area where I typically, assuming everything else is in place, I'm seeing the highest probabilities for incorrect configurations or at minimum suboptimal configurations, because it's a pretty complex part. So I'd like to start out with, on a very high level, how does the AIX-IO stack look like? You have an application like Oracle. Under it, you have 3 options to access to go to I/O. That's raw disks, raw logical volumes, and of course a cooked file system like JFS2, NFS, or others. I want to point out ASM option. If you use ASM, at this time you can either use raw disks or raw logical volumes. If you utilize a cooked file system, of course, typically today it's JFS2. The light blue areas illustrate where key data caches exist. Of course, in the Oracle database, we talked about last week the database buffer cache. Then we have in the middle of the stack, you see the VMM, virtual memory management, where with JFS2, the JFS2 file system cache is hosted. And if you look closely, you see with ASM that file cache doesn't play any role. Below that, we have then the logical volume drivers. If you use logical volumes, multipass driver, disk device drivers have some caches. The fiber channel adapters, for example, have some cache. And then we typically in our environment go outside the physical server to a storage subsystem. And of course, the storage subsystem has caches which are typically persistent. So if the server sends out a write IO, the storage subsystem says, yeah, I've written it. That data is protected in the storage subsystem, even if it may not have been physically written to disk or an SSD. And then, of course, at the bottom you have the actual physical disk or flash system, flash drive the data is persisted on. So this is a typical configuration I see today if you have a power server with AIX and a fiber channel attached storage. That is a typical configuration for production. So I'd like to start on the right side. We have our storage array where you have your physical disks, SSDs. To the left of that, you actually have, of course, your storage array controllers, typically in pairs for redundancy. Typically, a storage space is allocated, or LAN is allocated to a specific controller for management and actually doing physical I/O. Only if that controller 1, for example, fails, then controller 2 would receive ownership of I/O to that LAN until the controller 1 comes back. Just keep that in mind. Going to the left, in this picture, I'm showing virtual I/O servers. Of course, you could also utilize physical fiber channel adapters in your database LPAR. And then the parameters like num command elements, maximum square access size would move from the virtual I/O server also into AIX. But in this configuration, which I see mostly used, the physical fiber channel adapters are owned by the virtual I/O server and are shared between one or more logical partitions. On those fiber channel adapters in the virtual I/O server, you have control parameters like num command elements. How many concurrent I/Os can be outstanding at any point in time from that fiber channel adapter to the storage array. And the other one is max_x first size, which configures the maximum I/O size the virtual I/O server will drive or will support to drive against the storage array. It's typically 1 megabyte. There are some storage subsystems which also support 4 megabyte today. These physical adapters are then via endport virtualization, NPIV, mapped into the client LPAR. So it's just a blue AIX box where you can then, you have the queue on the NPIV adapter. It has its own num command elements. And you want to make sure that if you have many LPARs, that you may not have the num command elements too high to completely overload the physical adapters in the virtual servers. If you have limited sharing, num command elements, at least production environment, I typically see at the 2048 range. I have a little bit more reference to that later. To the left, you have the MPIO multipass I/O driver that is specific for your storage subsystem. In this configuration, that driver has to be installed in each client LPAR utilizing that storage subsystem. It sets specific characteristics, also things like queue depth, maximum square transfer for the H disks, which are then mapped all the way through the storage array. Then you have, of course, your queue for the H disks. This is controlled, the width of the queue or the depth of the queue is controlled via queue depth for each H disk. And the max underscore transfer here is typically Suggested is 1 megabyte with for an Oracle database. Default is typically 256K. But you need to make sure that if you change max and increase max and transfer, that your max underscore extra size on the virtual server matches. So it needs to be typically bigger. And then we have PBUFs, which belong to the logical volume manager, and also additional buffers to hold control information for IOs coming in through the disks. And then on top of that, you could have either ASM, as I mentioned, logical volume with JFS2, or other file systems. So from a tuning perspective, queue depth is really dependent on how many devices you are writing to. So how many H disks in the AIX operating system you're writing to, from all the LPARs being provided or supported by the storage subsystems you talk to. So especially in the context, for example, of EMC, you want to validate this with EMC, how many concurrent I/O does that storage subsystem support, and then ensure that you are not accidentally trying to drive more concurrent I/O than that storage subsystem actually can provide. So queue depth is the first kind of throttle of how many I/Os AIX will drive against a single LAN in the storage subsystem. The maximum for that queue depth is 256. Max underscore transfer, I already mentioned. Typically in an Oracle database, the default is 1 megabyte. So in the database itself. So you also want to adjust the max underscore transfer on each of the H disks, supporting your Oracle database, either JFS2 or ASM, to set that to 0x100,000 with megabyte in hex. Then on the adapter level, I already mentioned the num command elements, how many concurrent I/O each fiber channel can support. And you have that both on the client helper and the virtual server. I mentioned max underscore exercise. I want to flavor that a little bit. You do not want to reduce that number to, for example, if it's already at 0x400,000, you do not want to reduce it to x200,000. New adapters have higher or have more memory, so they already run with a larger setting. Max underscore exercise has also some implications on adapter startup of how much physical memory is allocated for direct memory access IOs. That's the reason why I mentioned here, you only want to change that after checking with IBM support. If you are unlucky, you can end up with, if after you changed it, that your system doesn't boot anymore, because you basically exhausted physical memory available to support DMA activities. That's all system version size specific. That's the reason before changing that parameter, talk to IBM support. Then there are two additional settings which are on the VSCSI adapters driver layer. So then track and the FC underscore error underscore recovery, they both have to do with how quickly AIX recovers from a change in passing, a pass going away, pass edit, things like your storage subsystem undergoes maintenance and half of the paths suddenly go away because you had to reboot the controller to apply a patch. But those two parameters basically speed up how AIX reacts to those paths being lost, redriving I/O down alternative paths to your storage subsystem, as well as if there is no surviving path to the LAN you're trying to write to, pushing those writes back as failed into the higher layer of AIX and potentially back to the Oracle database as a failed write. And at the bottom, there is this good article with some additional information, explanation you want to look at. I already mentioned pbuff and other buffers in the AIX-IO stack. The best command or easiest command to look at those buffers is a VM-set-v. You look at the last 5 rows, and you need to do it twice. It's a point in time continuously increasing values. So you run it once, wait 15 minutes, and look at it again. And only then you can say, okay, it's continuously increasing, and at that point in time, you need to do something. For example, you will always see something like the 2484 filesystem OS block with no FS bus for JFS. That will always be a above 0 number. But you can just ignore it because it will not change. Typically, if you have a cooked file system, right, this does not apply to ASM, of course, you are looking using JFS2, and you are looking at the external page of file system IO is blocked with no FS bus. If this number continues to increase, so not just 2 or 3 over several hours, but very significantly, then you need to take the 2 highlighted step here, increase J2 dynamic buffer pre-allocation. As the name says, it's dynamic, so you can just change it and we'll adjust how buffers are allocated. And if that doesn't work or it's not aggressive enough, you need to go over to the J2_N buffer per pager device, which you see it's IO restricted, typically only recommended to change with after checking with IBM support. A very good article with significantly more wording and text around and tips and tricks is linked here at the bottom. You may want to have a look at for additional background information. So if you look carefully at the page numbers, you notice that I just basically skipped 6 slides. So this is one slide, and you have 6 others similar to pbuff and GNOME command element and QDAPs, how to do it, how to look at it in the more extended deck. I wanted to add this one, even if I don't see the use of VSCSI in Oracle database environments too much anymore. I just want to highlight that with VSCSI, so the virtual IO server owns the adapter, and it owns basically the HDisk and makes it just available via the hypervisor to the client AirPower, that the NPIV SCD PCM, which is specific for your storage vendor. So you will have one for EMC, one for Hitachi, one for IBM, different IBM storage subsystems. That driver has to be installed on the virtual IO server, not in your client AirPower. The other point I want to make is that the VSCSI adapter, so there's VSCSI 0 here, at most can support 512 concurrent IOs. So it has only 512 command elements. It cannot be changed. So if you have a larger number of disks with significant QDAPs, you may end up with not having sufficient GNOME command elements in that one VSCSI adapter to support the peak IO pressure through all the HDisks. The solution to that is you basically just create additional VSCSI adapters and distribute the access to the different LANs over those different VSCSI adapters. Something you may not have seen or may not be aware of, this is a new feature, I believe, introduced with AIX 7.4 tier 7.2, not 7.4 because it doesn't exist. It's a typo, sorry about that. So 7.2 tier 4 is AIX fiber channel multiple IO queues. And it's basically, in the past, we had per fiber channel adapter one locked queue for all the IOs coming into that adapter. Now with the improved multiple IO queues, we have now multiple IO streams and locking, much finer grained locking to drive IO through a fiber channel adapter. So we can get significantly higher, especially IO rate, through a fiber channel adapter than we could in the past. I'd like to point out that right now this is only supported to configure on the physical fiber channel adapter. So in the configuration I had mentioned before, the physical adapter was owned by the virtual IO server. And on the top left, I show you how to see if your adapter supports that new functionality and what the current settings are. What you see here is a default with 8 queues and the IO setting. If you look in the client LPAR for the corresponding fiber channel adapter, those parameters do not show up because at this time they are not configurable. There will be additional enhancements, or there are planned enhancements, which are planned to make the IO queue extension also available on the NPIV level. But that is still in the plan. I do not know in what specific TL level or SP level for TL4 that will show up. So now switching from a little bit the AIX and details to a higher level on how do we actually, or what approach do we typically recommend to prevent IO hotspots and corresponding IO challenges. So in a long time past, there was the idea of, okay, let me separate all the indexes from the data files, and maybe even some specific data files from some other specific data files. That approach can provide very good performance, but only on day one. Over time, your data changes, your data volumes changes, your access pattern changes, and you suddenly will find, oh, this disk is now overloaded. And this other disk over there is not really that busy. So my pretty strong recommendation is to not try to do this data separation manual, but instead distribute IO as evenly as possible over all available hardware resources for your AIX-LV. That means, and that goes all the stack down to use all the controllers, use all the physical disk resources behind those controllers, utilize the fiber channel connectivity from your server through your SAN evenly, and then of course on the AIX side with the H disks, distribute the IO evenly over all those H disks, and that approach may not give you the highest performance, but it will be stable over time. You will not end up typically with hotspots for specific selections of data you have artificially created. And if you look at, for example, the approach with ASM, you will notice that ASM does exactly that. It stripes the data over all the disks in an ASM disk group. And our recommendation is typically have only 2 ASM disk groups with rack maybe 3 or 4, depending on how you do it. So from a little bit more practical, so we have the storage side on the right. This is a little bit a picture from history where we had spinning disks. I think there are still customers out there who have spinning disks, so their seek times matter. So you need to be careful on how you create your RAID arrays in the storage arrays. If you are on a flash system, this is not really that of an issue anymore. Typically, storage allocation is spread over most, if not all, SSD, flash drives you have in your storage subsystem. Those allocated spaces are then, as a LAN, given to AIX. In AIX, they show up as an H disk, like HS1, 2, 3, and over which you then do software striping, and I go a little bit more into what that exactly means. One concern I've heard from especially the storage teams is, oh, my LAN space is striped over all my storage subsystem. Why do I need more than one LAN, or maybe two, to host my whole database? That may be true from the storage perspective, but if you think back, what is in front of an H disk or LAN in AIX? There's a single queue. So if you have only one LAN or one H disk to host all your data from Oracle database, you have at most, even if you crank up all the way, 256 concurrent IOs you can drive. And that can be pretty disastrous, especially in a mixed environment of OLTP and long-running or large IO data warehouse queries. So what I would recommend, at minimum 8 LANs per, for example, ASM disk group as a minimum. And then, of course, Oracle size, how big your database is, may drive that to 16 or 32, because there's this 2 terabyte limit for ASM disks. So after discussing that, another issue I'm seeing a lot, unluckily still, and that is how the logical volumes which sit under the JFS2 file system are created. So here I try to summarize the different terms and how they work. So we have a volume group, which is basically a group of H disks managed together. In this example, I show 3. Each of those H disks is carved up into what's called a physical partition, or PP. They all have the same size within a volume group. So typically, you would also want to have all these H disks the same size. Then we have, on top of those physical partitions, or in the volume group, we create logical volumes. And there are 3 main kinds. One is mirrored strict, where you basically have 2 copies, in this case, of data backed by a physical partition of one H disk and a different H disk. And this is here, as you can see in top left, the 1 and 2, and 1 and 2 in red and purple. Then we have Oracle logical volume maximum spread. And you can see in this configuration, I told AIX, for this logical volume, utilize all H disks and utilize maximum spread, and that results in AIX allocating in a round-robin fashion physical partitions from the H disks. So first partition on the first H disk, second on the second, third on the third, then the fourth round-robin back to the first, and so forth. The problem is maximum spread is not the default when you create a logical volume. If you just create a JFS2 file system without a logical volume before to put it on, it will be created with minimum spread. Minimum spread means allocate all PPs from one H disk. If that H disk is full, go to the next H disk and allocate all the PPs from there, and so forth. So you will end up with hotspots. You will have, even if they have large databases, you will have disks which are way more busy than others. And you're not being able to actually get the I/O throughput and I/O rate you would expect from a storage subsystem. This is a very common area. If you just go into SMITI, so the AIX interface, control interface, and say, create JFS2 file system of that size and that volume group. Because under the cover, AIX will create a logical volume with minimum spread. To do it correctly, you first need to create a logical volume manually via maximum spread, and then you create your JFS2 file system on top of that manually created logical volume. That's the only way to correctly create a JFS2 file system with the maximum spread if you're utilizing physical partition spreading. And I'm going now into those software striping methods we have available within AIX. So this is all specific to utilizing JFS2. ASM is not impacted at all by this, assuming that you're using raw H disks, and has its own strip sizes and how you allocate space. So in AIX we have stripe using logical volume. This is a finer grain striping. So the smallest strip size, so allocated space on one H disk is 4 KB. Largest is up to 128 megabytes. I'm not sure if it's maybe even bigger than this now, in powers of 2. To create such logical volume, you can either use, of course, MIDI and specify, I want to have it striped, or you can use a command line with a -S and specify the strip size. From our perspective, Oracle drives scan IOs with the size of DB block size times DB file multi-block read count. So both are parameters of the database. And by default in 12 and later, if you don't set it, it defaults to 1 megabyte. So the recommendation is to set the strip size, so the allocate space on each disk continuously to 1 megabyte as well. Another thing to make sure is that you utilize scalable volume groups. I think that should be the default today. They also address an issue we had with old standard volume groups, where if a logical volume spread multiple H disks, we could end up with broken IOs, and you had to specifically create those volume groups with a flag. If you use scalable volume groups, which is everybody should do that today, that is not an issue any longer. So that was a fine level logical volume striping. It adds a little bit of the path length, but in my experience, it's a very, very low overhead to have that coarse grain striping. So key point, coarse grained 1 megabyte strip size. You do not want to use the 4 kilobyte or anything like that. The other alternative is PP striping or also PP spreading, which relies on specifying the maximum spread parameter in the logical volume, and the strip size in that case becomes the PP size. Typically, PP spreading works quite well with 8 megabyte to 32 megabyte PP size. For a very large database, 64 megabyte PP size may work as well. But you will probably notice, depending on your database table or index sizes, that some of the disks may be more heavily utilized because most of the data for that small index fits into a single 64 megabyte PP. And if that index is hot, that H disk will preferably be potentially hit statistically more than other H disks. So that's the reason why I suggest to keep PP sizes relatively small, and with the goal of keeping the number of physical partitions in a volume group below 50 to 60,000. You can create volume groups with significantly more. I've done tests with some 150,000 PPs, but that adds more metadata, so it uses up disk space. And you also find that some of the volume group, logical volume related commands are running slower if you get into those very high PP count numbers. To create such a scalable volume group with the correct PP size, you would do mkvg-S, lowercase s, and specify the PP size you want. If you go into SMITI and just say, okay, create me a volume group, use these disks, AIX typically tends to go with a very large PP size. So to utilize PP spreading as a method of striping data, you would utilize the CLI or specify the PP size in SMITI to be significantly smaller than the default. And of course, very important is, if you use SMITI, specify maximum range of physical volumes, the maximum spread parameter. If you forget that, you end up with a minimum spread, and that completely defeats the purpose of spreading. And I also provide you here with the CLI flag -EX to force the spreading. After you created your logical volume, in either case, either PP spreading or logical volume with striping, I typically recommend to utilize the JFS2 redo log information to be put inside of that logical volume / file system, and not have a separate redo log logical volume for that information. Also makes backing up data on a low level more consistent, because you have the redo log and the data within one logical volume, one set of disks, which is not necessarily guaranteed if you have a dedicated or accidentally utilize the default redo log file of that in that volume group. That's another issue I've seen, redo logs being incorrectly created. Best way against it, utilize the inline logging option when you create your JFS2 file system. A few more comments with logical volume striping. I'm not sure I have enough time. So typically, you specify all the H's in the volume group. So I take N here at that number. To grow that logical volume, it will grow in one physical partition. So if you went with the default of 128 meg or 256 megabyte, the smallest increment to increase the size of that logical volume will be 1 pp. Recommended, of course, is that, right, I have to take that back. We are now striping, so we actually have to grow every H disk with 1 pp, because we are striping over all H disks in that volume group, allocate to that logical volume. To grow that logical volume, we have to grow by the stripe width, which in this case is 8, times the PP size, which in this case is 1 gigabyte. And so the size increases you are able to do are 8 gigabyte, 16 gigabyte, 24 gigabyte, and so forth. So be aware of that there's a relationship between the PP size, that your stripe width, and what is the smallest amount you can grow that logical volume at any point in time. On top of the logical volume, you of course have your JFS2 file system. You can grow that file system with a smaller increment, but the physical space is still allocated in the volume group. So if you grow your file system, for example, by just 1 gigabyte, and you increased your logical volume by 8 gigabyte, you just basically threw away 7 gigabyte of usable space. That was a very simple example. one thing is really important to understand is if any of the H disks under that logical volume run out of space, you will not be able to expand or extend dynamically the size of that logical volume. Right? It's a strip of a stripe width, and you really need to have space on each H disk. So how do we address that problem? The recommended way today with current technology and intelligent storage subsystems is to dynamically increase the size of all LUNs in that volume group. Right? The assumption is that logical volume utilizes all H disks in the volume group. You would all then expand the size dynamically in the storage subsystem. That's your storage admin who would do that. And then the system admin would just run change VG-G to dynamically rediscover the new size without any outage whatsoever. And at that point in time, you can dynamically increase the size of the logical volume and then expand your JFS2 file system. Another positive side effect is that there is no change in the SAN infrastructure mapping pathing involved. It's really just in storage, allocate more space for each of those LUNs, and then on the AIX side, use that space. The only other option, if you use logical volume striping, is to create an additional set or add additional set of N LUNs to the volume group, and then expand the logical volume to utilize those 8 to new LUNs. That, of course, is, let's say, pretty expensive from an effort because you have to implement zoning, pathing, create new LUNs in the storage subsystem. All these things come into play. So if we do switch over to PP spreading, which is the alternative of doing software striping, I already mentioned the 50K to 60K PP in a volume group. In this case, you can increase the size of a logical volume under the JFS2 file system by 1 PP at a time. Typically, you do not want to do so because you really want to achieve even distribution over all H disks in a volume group. So you would grow your logical volume by number of disks times 1 PP as a minimum. And yeah. If any of your H disks runs out of space because you created other logical volumes for other purposes in that volume group and you didn't take care, you can still expand the logical volume, so grow it by PP, as long as there is unused PPs on any of the other H disks in the volume group. The result, of course, if that happens, is that you will end up with uneven I/O distribution and load over your H disks in that volume group. If you're running out of space, again, utilize SAN dynamic growth of LUNs to allocate more space to your LUNs and accordingly H disks, and then you can grow your logical volume. An alternative here is you can add 1 or more H disks or LUNs to a volume group, but then you need to also execute what's called a reorg VG, which redistributes the physical partitions from the existing logical volume evenly over all the H disks after the new H's were added. This is distributes the PPs, but of course it has no real idea of what is in each of those physical partitions. So it may not result in even distribution of, for example, a large table to over all the disks in the expanded volume group. So clearly the storage level expansion is preferred. Switching a little bit, okay, so we now talked about AIX and software striping, a little bit IO queues. So where does it relate to Oracle? Oracle is a database, has a number of areas where it stores data. And I highlighted the key ones here in blue. So we have, of course, the database files, index files, which are the biggest piece. We have our control files, which can be very I/O intensive at times, very critical. We have our redo logs to be able to recover a database. For example, if we had a power outage. We have archived redo logs, which are needed for longer-term recovery. Then we have flashback logs, which allow a DBA to continuously record changes and be able to flash back or roll back the database to an earlier point in time. Then, of course, besides the actual database files, we have the Oracle binaries, audit logs, Oracle process trace files, dump files, which can also sometimes generate significant I/O. Before going into mapping, okay, these specific Oracle files, what are the characteristics? A few terms. We have in AIX several mount options for file systems. So this is all applies again to JFS2 file system data usage. So buffer caching, which is the default. We have concurrent I/O, and I will talk about this in the next slide. Then we have additional options called release behind write and release behind read, and the combination of read and write, release behind. Those options optimize how quickly and how efficiently memory from the JFS2 file cache is released and put basically back on the free list after the write or the read completes. So for data, you do not expect to be having to be read or written again in a reasonably soon future. There is really no benefit of having it in a JFS2 file cache. And it may actually impact other I/Os which need free pages in the buffer cache and would have to wait for the LRU daemon to free up pages. On the bottom, there's a no access time, which I recommend to apply to basically all the file systems, assuming that you, from your auditing perspective, do not rely on access time information to a file. The modification time, so if somebody actually wrote something on a file, is still tracked. So backup utilities typically rely on modification time and not access time. So a little bit, still sometimes hearing, okay, what does DIO, CIO, and all these mount options actually mean? So on very high level, we have on the left, I show the database buffer, and it's writing to its data file. In this case, I show exactly one data file. A standard mounted JFS2 file system, there is what's called an inode log very early before you can do any I/O to a file. So you can have multiple readers, but can have only one writer. So as soon as one writer is in there, it blocks all other readers and writers with against I/O to the disk. And you see that sits in front of the file system cache. So if you have heavy concurrent I/O against the file, a single file, that is typically can result in significant queuing. And it shows up as high difference in what your AWR report reports as I/O service times and what your HDisk subsystem reports as I/O service time. Then we have the DIO option where we still have the inode log, but the file system cache does not show up anymore, so it's not involved. This is typically only used if somebody would be using JFS, which is a very old AIX file system. So today, you really everything should be on JFS2. With concurrent I/O, a database write goes directly against the file. There is no lock whatsoever in protecting against multiple writers. So to be able to use concurrent I/O, your application needs to control who can write where in your data file. Otherwise, you end up with data corruption. And Oracle database, of course, it's one of those applications who supports that concurrent I/O option. So I mentioned the different files. I provide you some characteristics of typical I/O sizes. For the data files, we typically suggest concurrent I/O in the majority of workloads. There are some characteristics, and I have a detailed slide on that one later on, where the JFS2 file cache can be beneficial. And concurrent I/O, as I just mentioned, completely takes JFS2 file cache and any prefetching from AIX out of the picture. The JFS2 files block size by default is 4 kilobyte. If you utilize Oracle with 2 KB block size, for anything, you need to make sure that the corresponding file system where that data file resides on is also set to 2 kilobyte, especially if you're utilizing concurrent I/O or direct I/O. Then we have redo log files and control files. The key point here is the write can be as small as 512 bytes from the database, or multiple thereof. If you're utilizing 4 KB redo block size, the minimum I/O size would be 4 KB, and I show the parameter on how you could override the default 512. If you utilize concurrent I/O, it is important that for redo log control, especially redo logs, that the file system you put those redo logs on is set to with an HEBLK size, it's a block size for JFS2 to 512. It's very important. I already mentioned the release behind read write. They can be very beneficial for archive video log mount points, backup files, locations, export import files. If you look at Nmon and you see the LRU daemon being very, very active while you do a backup to a JFS2 file system, I suggest do a dynamic mount-o remount, release behind write on that file system where you back up to. And you will see a significant relief in page scans and LRUD activity and significantly higher throughput for the backup. If you use concurrent I/O, it will utilize, with concurrent I/O, those I/Os for archived logs will be direct I/Os, means there is no caches, and the I/O size is driven directly by the database. So it's typically probably around the 1 megabyte I/O size. Then we have the flashback video logs. Again, a potential candidate for release behind read write. For Oracle binaries, do not use concurrent I/O or direct I/O. Very, very important. I've heard of some customers who tried it and then were wondering why binaries were corrupted and things like that. And I already mentioned the using no A time option for the file systems, Oracle file systems, where you do not care about the last access time of the specific included files. How do I configure concurrent I/O? The easiest and cleanest way today, files database option file system I/O _ option is equals set all. That is not the default. So SH is the default. So with set all, then when you start up the database will open all its files with concurrent I/O. There is no need, and you do not actually want to utilize AIX mount option CIO or DIO. So that's the preferred option, and the Oracle database does all the work itself. With current Oracle release versions, utilize this option still allows you to utilize third-party backup tools, for example, to read the Oracle data files despite setting set all. And I already mentioned that CIO file system mount option is an alternative but not recommended. Just checking what else is on here. At the bottom, so one thing I want to point out, if you use concurrent I/O, so if you didn't use it before and you switch to concurrent I/O, remember what it means. It means you're taking the JFS2 file buffer cache out of the equation. That, if you don't change anything else, that typically means a significant increase in physical I/O to your storage subsystem. So if you go from non-CIO to CIO, you typically have to adjust the DB cache size to get more, to basically make up for the lost JFS2 buffer cache used for the Oracle data. If you manually change the DB file multi-block read count, you may want to verify that that is correctly set as 1 megabyte, because that is what the database will use, for example, for database scanning. If your SAN supports 4 megabyte I/O sizes and you have set up the HDisk max transfer and the adapter setting as well, then you can also increase DB file multi-block read count to a 4 megabyte. As I said, it's calculated as block size times DB file multi-block read count. That is the maximum I/O size Oracle will drive. If you set it to 4 megabyte and you leave your database as 256K, that means if the database does a scan, AIX will have to break this 4 megabyte I/O up into corresponding 256K chunks, send them down to the storage subsystem, then has to aggregate the response for all those I/Os inside of AIX, and then send the result back to the database. You typically see some pretty large I/O service times in the database if that happens. So it's not efficient. You want to make sure that the database I/O size matches the HDisk I/O size. I mentioned the redo lock, the 512 byte. So here's an example of what happens if you do not adhere to that. You get what's called demoted I/Os. At the bottom, you can see how you can check if you have that. And at the top, you can see what happens to your, for example, log file sync times in the database if you have demoted I/O. 28 milliseconds compared to 2 milliseconds. And as redo is extremely sensitive to latency, your database will really suffer. AIO, it's all Oracle databases today should utilize async I/O, means asynchronous I/O driven from the database through AIX. Here, the standard parameters we do not really change today. The defaults are good in most cases. If you're on an older AIX release, please refer to the APA I show there. There were some issues which have been resolved. There's this latest AIX-LV, and which can impact how quickly AIX ramps up AIO servers to handle asynchronous I/O requests. On the Oracle side, this async I/O equals true. That means we're doing async I/O. That's the default. We have the file system I/O options setting. Async H is the default. Set all is recommended in most cases. We have the DB writer processes I already mentioned last week. They are calculated based on 1 per 8 logical processors. So with SMT8, that may actually drive too many. So you may want to adjust it. And we are not utilizing DB writer I/O slaves. So you do not want to set that parameter if you're using async I/O. A new feature with AIX-LV Tier 4, which has impact or can have impact on Oracle databases on top of JFS2, was made available with 7.2 Tier 4. So it's the reserved but not allocated feature. You can configure it globally or as a mount option for file system. And it basically can significantly reduce the fragmentation of Oracle or of files on the file system when you have a larger number of concurrent processes allocating space in parallel for different files. So for example, if you do a parallel import, if you have, parallel import is a big one. A restore from a backup is another one if you do it in parallel. Those, if you use those functions, then in the past you could end up with significant fragmented files on the file system. Means you have a lot of small pieces all over the place on your logical volume, which means if you do a scan of the data, AIX has to spend quite a bit of time on trying to find the corresponding pieces to put the data together. With this new option, it allows you to tell AIX, okay, if I create a new file, extend the file, reserve that much of continuous space for me for future writes into that file. So it significantly reduces the number of extents and makes the JFS2 use more efficient. You get less inode locking problems, both on the directory layer as well as on specific file layer. And at the bottom, I have the examples on where it's important. So this is a quite new feature, and I would recommend to set it to 512. So the maximum value allowed in your configuration. So improving I/O performance, this is the approach I typically take. The first one is, do I have poor Oracle SQL plans? Do I do way too many physical I/O? Do I use indexes correctly? That's the first step you should take, and typically the biggest bang for your buck, and that's the problem, it's also typically the most difficult or most complex to actually do. The next one is getting more data into your database cache. So I have to drive fewer physical I/O to the storage subsystem. And then I have an example again on the Oracle in-memory option. On the other side, I can, of course, go with faster disks, so SSD or flash. I can improve my storage layout, and I already talked quite a bit about logical volume striping and PP striping, as well as spreading I/O over more resources. Really utilizing all the passing I have to my SAN, all the controllers I have in my SAN, all the disks, SSDs I have in my storage subsystem, to really provide the I/O throughput and I/O rate I need to support my database. So I skip this one. It's pretty straightforward. Buffer cache, you really, so 90% is for an OLTP database especially is not good. For data warehouses, quite often there is really no way to do it. Otherwise, it will be relatively poor. But for OLTP, you really need to focus that you get that to a very high 90s number to get a very performant Oracle database. Here's a little bit a dumb example. It's a little bit on over the top, but this is a real customer workload where the customer at that time, you can imagine, it's a little bit old, but he had a very small database buffer cache specified, drove a lot of IOs. He significantly increased the buffer cache to 100 gigabytes, which by today's standard is relatively low still from many databases. And he went from over 300,000 IO per second to less than 50,000. So having the hot data, which is frequently accessed by your queries in the buffer cache, is one of the key drivers for better performance. I mentioned the Oracle in memory before or last week. I just want to reiterate, if you have a data warehouse workload or a mix of data warehouse and OLTP, Oracle in memory can be a significant, can provide a very significant benefit in reducing I/O. So instead of long time basically reading 2 gigabytes per second on the top right without in memory, if I go to the bottom, I'm basically doing nearly no I/O at all to run exactly the same workload much faster. If you have now a mixed data warehouse and OLTP workload, taking all this large I/O scanning away from the I/O stream will significantly benefit your OLTP workload or any other workload going against the same storage subsystem. To improve, I already mentioned that if you go with faster storage, this is just a simple example from HDDs down to flash system, and this is actually not that much, it's just from 3 milliseconds to 1. But for redo, that makes a significant difference. Right? You can see my wait time at the top was 40%. So the database spent 40% of the time waiting for my log file sync to complete. At the bottom, it only waited 10%. So much better use of resources, likely much better throughput, more responsive database, and also all those things. Note that, and it's actually, you can see it if you look a bit closer, if you improve the latency of your IOs, for example, redo log sync, you will move the bottleneck in your database. If you look at here at the top, I'm only spending 20% of my database time on CPU. At the bottom, I'm now spending 26% of my time on CPU. So if you do not have enough CPU resources in the upper case, here in the bottom, after you remove that bottleneck, this can become a bottleneck now, the CPU. Right? You move from I/O bottleneck to CPU bottleneck. I already talked quite a bit about host level striping. ASM does it automatically. By this group, you can specify, and you probably should specify, the allocation unit size. It's basically the strip size used in the ASM disk group. And when you create your ASM disk group, you can specify the AU size you want to use. With larger databases, that should be 4 megabyte, maybe even 8 megabyte, instead of the default pieces. It also has impact on how large your ASM disk group can grow to and how large your database objects can grow to. I will talk quite a bit about JFS2, so I skipped that. IBM Spectrum Scale, the old name GBFS, stripes by default as well. And you can also specify the strip size with GPFS if you utilize GPFS instead of JFS2 as a cooked file system under your Oracle database. This is one parallel queries in I/O. That is something which you may not really expecting or haven't seen too much. So this is from an actual customer example. So they had 5 queries running the data warehouse type of queries, so very I/O intensive. This customer decided, okay, I run my parallel queries all sequentially, so no parallel. And you can see the runtime in blue for the serial execution. You can also see here at the top how long the DB files get at read, which is basically a large scan I/O. So 1 megabyte typically took. And you can imagine 2.7 milliseconds, that's pretty high. And we basically reach the storage subsystem throughput limit in that case. And you see this is concurrent I/O. So no JFS2 file cache involved, lots of I/O for the parallel processes. Now we switched the queries to parallel execution. You see from the real execution time, we saw a significant benefit. Right, so this is orange bars for the different queries. Every query improved with parallel execution. We were, of course, even more limited by the storage subsystem bandwidth. And as you can see, the wait time significantly increased. Right, 95 milliseconds for 1 megabyte I/O. And note this is direct path read, means an Oracle parallel process directly sends a read request against the storage subsystem and put it in its own PGA. So it's not shared, and it's in its own PGA. This is configuration by default. So if the same block had to be, or the same data had to be read by multiple parallel processes for different queries, each one of them would have driven the same physical I/O. Now, this is what the customer actually started out with JFS2. So this is where the buffer cache was involved with the parallel query. Parallel execution with the JFS2 file cache, and you see the direct path read dropped from 95 milliseconds to 607 microseconds. And without, if you go with the default of Oracle, you will find that JFS2 file cache can be beneficial because parallel processes do not utilize the database buffer cache by default to store their data or share their data. So every parallel process, every time you run it, they physically read the block again. If you run the query again, they do exactly the same again. So Oracle recognized that as an issue, and they have now provided the option which is called parallel degree policy, auto or adaptive, which allow parallel queries to utilize part of the database cache to store data. So instead of every parallel process reading the same block or the same data over and over again, some of that data can now be found in the database buffer cache and can therefore significantly reduce the physical I/O workload driven against the storage subsystem. So if you're running through this issue, I strongly recommend to have a look into the parallel degree policy and try it out if it helps your parallel query plans. Now switching topic back to AIX. You can see it's a little bit cross-country, but there's a lot of material, so you probably want to look back at it. If you're using ASM, I strongly recommend to utilize two features available with AIX. One is rendef, the other one is logdef. ASM writes its own header block at the beginning of each disk. If you create by accident, or your system admin by accident says, oh, I want to use that HDisk to create a logical volume group, or a volume group, in the past, it has happened that, especially with older AIX releases, there's no protection. So the volume group just takes that HDisk, writes its own header, overriding the ASM header, and you're in pretty bad shape because you just lost an HDisk in your ASM disk group. So the first thing you want to do is you want to give your ASM disks a meaningful name. I typically recommend to put something like ASM into the name, and maybe even if it's for data disk group or for redo disk group or for Oracle Rack cluster disk group, put that, code that somehow in the name. And it's very helpful to figure out, okay, what role, what disks specifies, and then also make sure that I get the correct disks when I create an ASM disk group, for example, in the installer. I also strongly recommend that you leave the HDisk string at the beginning unchanged. Otherwise, there are some tools which rely on HDisk as the first part name. And if that's not there, they don't recognize the disk correctly. Or if you try Nmon, look at disks, and it doesn't have HDisk, you're not getting what you would expect. So I strongly recommend leave the HDisk, put some string, end with a number. So rendef, very simple to use, dynamic. Lockdef then allows you to lock down the device against any other changes, including adding it to an AIX volume group. And you can even specify a description text which shows up if you run LSPV. Here's as an example, at the bottom, this HDisk ASM10 has, of course, no PV ID, but this is a string I specified. Okay, this is an ASM disk, so every system admin should know this is a disk I can and should not touch, and that it's locked. So strongly recommend utilizing in an ASM environment, rendef and lockdef. Now a little bit a different topic. This is mostly in the context of ORC-REC. So if you have the StoreWise V7000, I'm not going into too much detail because you can read this yourself. I want to especially highlight the article at the bottom, where there is additional information. Okay, why exactly or what happens if I patch my stored subsystem controller? Why do some things suddenly fail? Right, for example, pass to a disk go away, and Oracle with 11 to 12.1 did not handle that well. With starting with 12.1 or later, that is already in place. This is a little bit of a, let's say, teaser for Power 9 system. If you're still on Power 8 or Power 7, we have now hardware compression, supported compression. We have a specific new command, which is called XGZIP, which utilizes that new hardware supported compression. The output is a standard GZIP file you can move to anywhere else you want and extract it. In the context of Oracle database, you can utilize it to much more efficiently compress, decompress, import, export files, or backups, or archive video log files. It's very fast, and to prove, I actually have done a small test. Because of time constraints, I'm not going into each and every piece here, but a single compress on a file system, I think with 200 gigabytes, with just a GZIP, single tar, GZIP, no physical I/O involved, so all data was in cache. I wrote to /dev_nar, took real 2 hours 18. And it's really completely CPU bound, single CPU to do the GZIP. If I do the same with the XGZIP, it took me 5 minutes, 3 seconds. But it doesn't end there. If I go parallel, I can compress up to 50 gigabytes per second. So I've compressed here, I think it was 1.1 terabytes in 1 minute, 50 seconds. And if you look in the middle, the CPU is not becoming the bottleneck anymore. What is the bottleneck is how fast can I get the data into the XGZIP, how fast can I write it to disk. In this specific case, as I mentioned, I'm not doing any physical I/O. It's really as fast as possible driving the hardware compression. So whoever is using GZIP in their business and you are now running on Power 9, I strongly suggest to reread these 2 pages, get the XGZIP command, get the additional hardware compression library to utilize that hardware, and just replace your GZIP with XGZIP, and you will see significant benefit. So that completes my I/O, and as we have not that much time left, I just continue and try to keep a little bit of time at the end for Q&A. On the network side, the key point I want to make is you want to adjust your TCP send and receive space. Oracle installer actually, I believe, checks that. You want to have the TCP IP sliding window, so RFC 1323 set to 1. If you are on 671 or later, and you are running batch processes on your database server, so you could utilize for those the new TCP fast flow, which is a more or a slimmed down execution stack to connect or to transmit data between a process and the database on the same physical server. So if you have that kind of configuration, you want to set this to 1, which will improve the performance of your loopback connection, so within the same ARPA. Then there is a TCP_no delay. My suggestion is to set that on the adapter. We have seen some, especially in the context of rack, that you do not want to set it on with the NO, because it can create a significant additional packet storm on the rack interconnect, depending on how your system is configured. So suggestions there, don't change the default setting in NO on AIX. Instead, set it with a TCP_no delay on the network adapter directly. And I'll show the command at the bottom. Important patches for deployment of Oracle on AIX. Key document, this is really, you should have, every DBA and system admin should basically have on its calendar, check it every 2 weeks or something like that, or at least every month, if there was an update. There's a lot of the material I covered last week and this week is included there as well, or at least parts of it, from very specific command executions. And it also includes key AIX APARs for different AIX release levels, but it also has key Oracle patches, which we believe as IBM as critical customers should be aware of and should likely proactively implement in their environment if they run the Oracle database on AIX. So that document is really a key reference with additional references then to other documentation. At the bottom, I provide a little bit more recent issue where you may want to refer to the APARs. I list here where ASM startup is slow because of disk discovery. This is a very new the database release schedule. I put in, this is directly from the Oracle my Oracle support website, and I added the AIX release support information for the different Oracle releases. 11.204, which is basically kind of that. So if you're still on 11.204, you better get to a newer release. And if you look carefully at the screen, the newer release at this time would really be 19C. That's the only longer-term support release currently available. So you see 18C will be pretty soon already out of support next year. So 19C is typically the version you would go to, and that is support on AIX 7.1 and 7.2. These are a little bit, I assume every DBA and sysadmin is aware of this. If not, have a look and make sure that you have this in place. It should be, it's on current AIX SP level, it's included, but they have this can be a pretty significant issue if you're not aware of it. and start out with an incorrect AIX TLSP level. If you're running Oracle Grid install, there are some issues documented also on Oracle support with OpenSSH timing out. And if you look at the document, you will see how to get around and fix it. Some additional parameters here. The key one I want to point out is you may want to look into the AIX_TC cache equals on. So if you are not changing your time zone information, and you have lots of date functions in your database code, this could help improve the efficiency of those functions, because they all rely back onto, okay, what is my time zone information? That could be a significant benefit. And I think this rest I've already covered. Then additional key resources. This is for Oracle, from the Oracle support side, key documents you may want to look at. The one on the top, which is referenced in many places. I checked it 2 or 3 days ago, and it's actually broken, that link. So I'm not sure if Oracle is putting out a new version of what's going on, but I hope they just updating it and making it available again. But I wasn't able to check it, but all the others are accessible. Then we have IBM Tech Docs, and you probably have not heard it, but it will be sunset on August 31st. All the material will move to IBM support. Supposedly, the links for the different documents, as you see them here, are redirected to the new location. I have not been able to verify that myself because it's not September yet, but I just want to make you aware of it. But there's quite a bit of technical material available on Tech Docs you want to look out at or for. And that is basically I have. And Joe, as I mentioned, I have no problems fitting in all the 90 minutes. So I have some time still to answer questions. So how do you want to handle it?
So Ralph, I don't know if you can see the questions pane and maybe pop in there and take a look at that. While you're looking that up, I'll just tell everybody that, like I said earlier, the Q&A document from last week's session, I haven't quite gotten into the wiki yet. I will do that yet today. I'm sure we won't get through all the questions here, so we'll pull the questions and Ralph can look through them, and we'll put another document up for this week's as well. Not sure when we'll get that done and uploaded. Ralph,
okay,
are you able to see some of the questions? You can pull out some of the maybe more.
Yeah, so that somebody asked about GPFS. Can I use it instead of JFS2? Of course you can. GPFS is a spectrum scale, which is IBM spectrum scale, which is the correct current name, is fully supported with Oracle database. So it's a clustered file system you could utilize with Oracle RAC, for example, and of course also for single instance. In regards to best practice for PBUF and QDEPs, I thought I had mentioned it quite a bit. I suggest to look again at the presentation, and I provided 2 links to IBM documents which step you through, okay, how do I evaluate, do I need to adjust the QDEPs, how do I do that, for example, or the PBUFs. The extended presentation set will also have additional slides to cover those topics. It's a little bit, it depends on your configuration, your workload, your storage subsystem. So there's no generic answer, yeah, increase your QDEPs to 128 for every workload. Your storage subsystem may not like you.
So just on that note, yeah. Ralph mentioned the extended presentation. So there is an extended presentation which I will put up. That Ralph just said wait until after this is over. So I'll put up, just like last week, an extended presentation on the wiki as well.
Mm-hmm. So that's another interesting question in regards to regarding data striping, new wisdom. Does it mean to avoid separating data file volume groups into one large volume group versus many small ones? I typically suggest to have a relatively small number of volume groups. It depends on how many or how big your database is. The simplest one is I have a volume group, one volume group, and I have file system for data index and a file system for redo, and I have another file system for archive. That's the simplest way. That would really distribute I/O over all disks equally. If you have very heavy redo activity, you may want to separate redo out, for example, into a separate volume group so that I/O driven against the redo H disks do not conflict in any way with I/O against your data and index. So it depends a little bit on how heavy your I/O is. But I would definitely recommend not to piecemeal into many volume groups with a small set of disks. Let's check what else we have. Not sure that's a question about the next algorithm parameter. I'm not exactly sure what that refers to. Languages to have.
So let's take one more, Ralph, and then we'll wrap up here, and we'll just do the rest of them in the document. Okay.
Okay. So that's one question. What is maximum supported num command element for VSC adapter on NPIV clients 2048? But go back to the presentation, to that page. It depends a little bit on what AIX release and TR level you're on. There were intermediate, I think on the AIX-7.1, Tier 2, Tier 3 configurations and different virtual server configurations. There were limitations and issues of what values could create instability. So I suggest if you're on one of these older releases, look at the presentation again and review the APARS.
All right. So again, the presentation will be up on the wiki. The replay, I'll put a replay link up on the wiki as soon as it's available. It takes WebEx a while to get that done, then I have to download it and put it on YouTube and all that. But hopefully I'll get that up there by tomorrow morning, and we'll get the questions. We'll capture those and try and answer those, and I'll put that document up on the wiki as soon as we can. So otherwise, I think we've run over here, so I think we better close this down. And I just want to say thanks, Ralph, for 2 weeks of just an intense amount of information on Oracle best practices. There's just a lot of stuff here, and I know people, and just from comments from last week, people are going to be going and looking at the replay just to catch up. So really appreciate it, Ralph. Thank you.
Yep. Thank you, Joe, for hosting, and everybody, thank you for taking the time to listen to this presentation. I hope it was helpful to you. If you have specific follow-up questions, we will try to answer the Q&A. So if you have one last minute QA, you can still quickly put it in. Otherwise, I think I have provided my email ID if you have a question, and I'm happy to field those.
Exactly. And I hope everybody stay safe out there, and I'll be sending out invites for September sometime later in a week or two, probably not next week. So stay safe. Have a great Labor Day weekend. Bye.